So compound interest and times per year. So let's say I'm looking to figure out how much money I'm going to have in my bank account. That's what this A represents, the amount I'm looking for after a certain amount of years or time. P represents principal. Principal is my initial investment. Like, for example, I put $2,000 in the bank and I want to know when is it going to reach $3,000 given a certain rate. 1 represents our 100% that we're going to be adding to, like on the population one from before. If I'm gaining 5% per 5 years, something like that, then I take 105% of my principal. So R represents our rate and N represents the number of times it compounds. So if it's only once per year, right, if I'm only gaining 5% per year, this would be 0.05 over 1, so just 0.05. But if it were 0.05 compounded every 6 months or something like that, then you would put 2 down here. So it splits that 5% up into 2 different chunks. So N here is also number of compounds per year, and my T represents time. How long is it going to sit? So here's an example of what this would look at. Oh, and this is for interest or population, but when you see this formula, generally people are talking about money because people are interested in money. So let's say I have a principal of $1,000 and my rate is 6% and it's compounded quarterly. So that means 4 times per year, which you probably could have figured out, but just in case. And here's my question. When will it reach $2,000? So when you set this up, you're going to have $2,000 is the amount that I'm interested in. $1,000 is my principal, how much I started with. 1 will always just be a 1. 0.06 because it's not 600%. That's what it would be if you put in 6 instead of 0.06. And then 4 being the number of times per year, it compounds. N, 4 times per year. T, how long will it take? When will it reach $2,000? So that's the T that I'm interested in. So we're going to leave that as a variable. So how do I work this out? Let's just start plugging away. What's the first thing I'm going to eliminate? Well, I'm going to have to divide out my 1,000. So 2, in other words, I'm looking for a doubling, is 1 plus 0.06 over 4 times 4t. Got that from dividing out my 1,000. 2 equals plus what is that over 1? I'm going to use my calculator. So 0.06 divided by 4 is 0.015. So 0.015 4t plus 1. 1.015 4t. Now, I'm looking at that equation and saying like, oh, gee, what do I do with that? I'm going to rewrite it so it's more legible. How do I eliminate this right here, or in other words, how do I access this t, being as it's an exponent? Well, I know how to solve exponential equations, right? I use a log. So I'm going to use log base this because that's how I like to do log problems. Because if I take the log base 1.015 of 1.015, this is going to become a 1, right? I wrote that rule over here in your notes to remind you why that works. And then if I take the log of a number with an exponent, that becomes my multiplier out front. So I'm going to use my calculator to figure out what this is. This is just 1 times 4t, so 4t. And then control log base 1.015 of 2 is 46.5555. My calculator just says 4 5s, but it's possible that it's a repeating 5, so I'm going to go ahead and use that term and say divide by 4 here with my calculator. And so t must be worth, what term they've given me here, is 11.6389. I mean, I'm not going to go out further than 3 decimal places. 6, 3, 9. So in order for my $1,000 to become $2,000, it's going to take me 11.639 years. Well, 639 years, I don't really know what 639 years is, so I'm going to take 0.639 years. How many? We're going to convert it to months, so multiply that by 12. So 7.5. You could really work this all the way out to the days if you needed to. Let's do days instead. 0.639 times 365 days. So 11 years and 233.235 days. So let's round that to the nearest day, and 233 days. Wow, exciting.